We are about to move. This was safe traffic. We're going to move on to safe water. So this is now Team Xylem from Aalto University and University of Science and Technology in China.
Hello everyone. Good morning. Let's begin by reminding ourselves of an important, yet not a very widely known fact, that only 1% of the world's total water is actually suitable for human consumption. That includes water for industry, agriculture, and also drinking. And to make the matters worse, 30% of that 1% is actually lost during the transportation. Now, we would think that this problem might be restricted to the developing countries, but not so. These are the cities that you see on your screen that will run out of water, in the next 20 years. And to tackle these water scarcity issues, So these are the cities that will run out of water in the next 20 years. And this glass of water might eventually be the reality for all of us. And to tackle these water scarcity issues, our task was to optimize the water infrastructure network in the Chinese context. Now, China is a huge country, but water shortages and water crisis are hampering China's quest for economic prosperity and development. And this is where we come in. We call ourselves Team Optimizers. We are a bunch of diverse individuals from different backgrounds and cultures. We are oceans apart, but we are united in our aim to resolve this ongoing water crisis in China. Now, we understand that the most of the water that is lost during transportation is through leaks. But how are those leaks actually detected? Now, in China, acoustic listening is the most common method of detecting leaks. Now, this is how it works. The guy drills holes on the ground and listens to the sound of the water underneath. He has to drill multiple holes to be able to detect the leak. And in drastic conditions, and difficult weather conditions, this is not always possible. And we understand that clearly there is a much better way to do this. That is where our sponsor, Xylem, comes in. They have a product technology concept called Sahara, which is one of the best, a state-of-the-art leak detection mechanism that works in service line pipes for pinpoint accuracy detection of leaks. Now, how Sahara works is through insertion of a wall into the underground, and it moves with the flow of water to detect the leaks based on acoustic signal variation, which the operator on ground can analyze. And once the leak has been detected, the operator on the ground marks the surface. But what actually happens after a leak has been detected? In China, bureaucracy is heavy and the processes are slow. We understand that if a leak happens under a commercial street, a traffic congested area, or a busy locality, the water company's maintenance workers will not go through the hassle of repairing the leak. And that will result in water continuously being lost and people not even knowing about it. On an average, the water revenue loss per leak amounts to $6,000. And on a cumulative basis, annually, that amounts to $21 billion. And this is what pipe repair looks like today in China. Excavations, digging, rubble, disruption of daily life, and not to mention unhygienic conditions for the workers and pollution.
And this is where our concept of repair comes in. Repair is a trenchless, sectional, real-time repair inside of the pipe. It works in three phases. The first one is insertion. The repairer can attach on Sahara, so the whole device can be inserted from a very small valve inside of the pipes. So no excavation now. The Sahara can help to detect the leakage inside of the pipe. And the operator on the ground can monitor the whole process on a very simple user interface. You can see from the picture, the acoustic signal variation is really high, which means this leakage exists. It can also be verified by the live video on the right side. You can see this leakage there, and that's the insertion path. We will talk about the inflation. If leakage really exists, the operator on the ground can hold the repairer to stay the position of the leak. Only they can click the deploy button on the user interface. The repairer will be released from the Sahara and inflated itself to block the leakage. And then we'll talk about the retraction phase. In retraction, if the repairer is in place, the operator on the ground can verify it by looking at the user interface again. You can see now there's less acoustic signal variation, and the repairer is already there to block leakage. So no leakage in the live video. In this case, the operator can retract the Sahara back from the previous wall and leave the repairer stay inside to block the leakage. So that's the whole process of our concept repairer. Only 3 steps: insertion, inflation, and retraction. It's simple, but it's effective. And also we learned that the average leakage size in service line is only 5 centimeters. Actually, our concept repairer is 15 centimeters. So it's definitely enough to block almost all leakage in service lines, and it can still move freely through different branches and burns in the network.
Now we understand that water companies in China are operating with limited budgets for leak detection and repairs. But at the same time, water shortages are China's #1 long-term priority. The traditional methods for service line repairs in China cost $1,000. Meanwhile, the same process in the United States costs $10,000. But we believe with the materials and the processes involved in our concept, we can do this for a fraction of a cost. But not just that. Every time companies use our concept to repair the leaks, they will save water revenue amounting to $6,000. And with this, we believe that your glass of water will remain full. Yeah, and just one more thing. I would like to invite the team on the stage who made this happen, and would like to extend gratitude towards the teaching team and our corporate sponsor Xylem for their insights. And we would like you to share, to see our prototype at our booth, which is right over there.
All right, questions to our team optimizers.
Hey, so what effect will this have with the water? So the material that the repairer will be made of, will this affect the water? Will it have any runoff into the water?
So we actually have a slide for that. And yeah, so this is how it looks like. And basically, the materials that we are using for our concept are based on regulation safe and water safe. So in terms of rubber, I can give you one example of the rubber that we have thought about is EPDM rubber, which is water safe and can be used easily. And you see the concept of inflatable steel here, which is food grade and can also be used with safe drinking water.
Awesome, thank you. Oh, also, what is the lifeline of this?
So yeah, it's a good point that you brought it up, because that was one thing that we were struggling with for most of the project. Initially, we were only focusing on rubber, which would last around 2 years, based on expert opinion. We haven't tested, of course, for that long. But then we came across this concept of using inflatable steel, which is actually metal, and that will last, if not permanently, then at least up to 5 years.
Okay, other questions? Christine.
Thanks for your presentation. I was wondering what the decreased diameter of the pipes has, what impact that has on the flow of water now that the diameter is smaller.
Okay. That's actually also a very good insight because we ran into that problem during our testing. So that is a problem, but when we discussed it with the maintenance workers, the length of this module is only 15 centimeters. And that compared to the length of the pipelines is a very insignificant amount. So there will be pressure difference for sure, but it will not be enough to have any impact on the pipe's integrity. So, but that also depends on the material that pipes are made up of, but in most instances it will not have impact on the pipes.
Yeah, you said 5 years coming back to the end of life. So do we have thought about how to get the stuff out of the pipe when it's not working anymore because you cannot repair the second time? You say it's 5 years, and what you do then, you cannot patch the patch, and then, you have thought about that?
Yep. So the way we have imagined it to work and the way we have tested it, so that problem can also happen if there are two leaks which are coincident or one after the other. So our device is, when it is compressed state, because it is inserted in a compressed state, and then it is released. So when it is in a compressed state, it can go through the other device. So even if you have to extract it out, we also have grippers within the module that can be used to extract it out. But in most cases, when we have come across during our research, sometimes it does happen that the device that is used to fix the pipes remains inside, but the pipe decays. So you have to replace the pipe at the end of the day.
Okay, there's a question in the front. Amit, thank you.
Thanks. Thank you very much. If the thing breaks apart and is carried away by the flowing water in the pipe, do you think there is a risk that it could clog other pipes in the water network that are maybe smaller and then lead to much bigger problems because some areas don't have water anymore or something like that?
Yes, we did think about that, but that problem, since this is based in China currently, and in China they have these valves at each 1 kilometer distance. So those can be used to extract it out if, in case it is like dislocated from its place.
Any other questions? Okay, thank you. Excellent job.